Hello, my little avocados, and welcome back to my science studio. So, today we're going to be continuing on with our mole concepts series of lessons. Last time we talked about what the mole is, what Avogadro's number represents, and how to find the molar mass. Now that we hopefully understand those ideas, we're going to start using them to solve problems. Specifically, those two-step problems where we convert between moles, grams, and particles. So, our learning objective for today is that hopefully by the end of this lesson, you should be able to convert between moles, grams, and the number of particles using molar mass and Avogadro's number. And honestly, the best way to learn this is just to walk through some examples together. So, let's start. In the first question, it's asking how many grams are in 3.50 moles of oxygen gas, or O2. I always tell my students to start with what you're being asked. So we can go ahead and write question mark grams of O2, right? How many grams are in 3.50 moles of O2? That's what we're being given. And here's the key tip. Anytime you go between grams and moles of one substance or moles to grams of one substance, right? So vice versa, you're going to use molar mass. And remember, molar mass units are always grams per 1 mole. So if we have moles and want grams, molar mass is our bridge. But first, I urge you to not fall for the diatomic trap. Remember, oxygen gas is O2. So the atomic mass of O is about 15.999. Times 2 atoms, we get a molar mass of 31.998 grams per mole. Do not forget about these 7 diatomic elements. There's a great mnemonic for that. It's have no fear of ice cold beverages. Anytime a question gives you nitrogen gas, oxygen gas, chlorine gas, etc., you have to multiply the atomic mass of that element by 2. So now that we have our molar mass, we can go ahead and plug this into our setup. Remember, the question is giving you 3.50 moles of O2. So we're going to go ahead and create a parentheses, or you can also just put a multiplication symbol. That's totally okay. Write a fraction. And what you got to ask yourself is, okay, what can I put in the denominator to cancel out my given units? So the units on the bottom have to match those that are given to you. So if I put 1 mole of O2 at the bottom to cancel out my moles of O2, I can go ahead and place the grams at the top. And we found that the molar mass of O2 is about 31.998 grams of O2 per 1 mole. Now we can go ahead and multiply. So 3.50 times 31.998 grams, we end up getting 111.993 grams. Now, because the question is giving you 3 significant figures, right, in 3.50, you have to report the answer to 3 sig figs as well. So looking at this third significant figure, you look next door to it. Because it's above a 5, you're going to round up, and the answer is 112 grams of O2. Okay, now let's go ahead and try this next problem. The question reads, how many moles are in 75.0 grams of NaCl? I encourage you to pause the video and try it on your own first, and when you're ready, press play and we'll go through it together. Okay, so the question is asking for how many moles of NaCl. So we can write question mark moles of NaCl are in what you're being given, 75.0 grams of NaCl. So we have our setup. Unlike in the last problem where we had moles and wanted to get to grams, now we have grams and want to get to moles. But remember, anytime you want to go from grams to moles or moles to grams of the same substance, you use molar mass, right? Because the units are grams per 1 mole. So we're going to go ahead and open a parentheses and draw a fraction. What has to be at the bottom here, as far as units are concerned, in order to cancel out the grams of NaCl? Right, the grams of NaCl. So what are going to be the units at the top then? The 1 mole of NaCl, right. So this is just me putting units in and not even plugging in numbers, and I'm already well underway in my setup here. Now you're going to go ahead and find the molar mass of NaCl. We have only one atom of Na present, times the molar mass of Na on my periodic table is 22.990. And chlorine, the same. We only have one atom present, times the molar mass of chlorine, which is 35.453. And when we take the sum of these two atoms' atomic masses, we end up getting 58.443 grams per mole. So we're going to plug in the 58.443 grams of NaCl at the bottom, and then the 1 mole is left at the top. Again, why? Because we want to cancel out the grams. The grams go on the bottom in this case. Now we're going to plug it into our calculator. 75 times 1 over 58.443. Remember, it's the same as saying 75 divided by 58.443. And that gives us about 1.2833 moles. But we got to use our rules for sig figs, right? So if the question is giving you 75.0, there's 3 sig figs. So your answer has to be reported in 3 sig figs. So you count, and you see that the 8 is the third significant figure. You look next door, the 3 is below a 5, so you keep it the same. So our answer is 1.28 moles of NaCl. And one quick tip before we move on is I highly recommend you always use the periodic table that your teacher or professor gives you on your exams, because different tables round differently and your test answers will match theirs. So my advice to you, I was taught this when I was in college. Don't round until the very end, especially when you're dealing with molar mass. So I don't advise, for example, rounding sodium early on from 22.990 to 23 grams per mole. I would keep as many decimals as possible until the very end, so your rounding is incredibly precise when you report using the correct number of sig figs. But that's just a little tip on my end. Again, use the table that your teacher or professor gives you, and you should be okay. Okay, you guys, now we're going to go ahead and tackle some multi-step problems using all the tools that I've taught you in the last lesson and in the current one. Specifically, I'll be teaching you how to convert between particles to grams and grams to particles. And I like to explain this concept using my bridge analogy. So hear me out. I want you to imagine that you are in my fictitious world. And in my fictitious world, you are going through this beautiful tropical oasis. And this is going to represent the gram. And you're walking and you're walking and you encounter a river. And across the river, you see at a distance the desert. The desert is going to represent your particles. Remember, particles are things like atoms, molecules, ions, formula units. But what is the one thing they share in common, these two completely different lands? Right, they share a bridge. You must cross this bridge in order to go from the gram to the particle. And this bridge is what I like to call the mole bridge. You have to get through the mole in order to get your way across. And so how this generally works is, let's say you want to go from grams to particles. The flow of your steps should be from grams to moles first, using molar mass, and then you go from moles to particles using Avogadro's number. And it doesn't matter what those particles are. Again, it can be molecules, atoms, formula units, ions, it doesn't matter. Particles are particles. You use Avogadro's number. And of course, as you would guess, if you want to go the other way around, where you start at particles and you want to get to grams, the first step would be to use Avogadro's number, right? To go from particles to moles. And then to go from moles to grams, you use molar mass. And if you remember from my last lesson, Avogadro's number tells you that in 1 mole, there are 6.02 times 10 to the 23rd particles. Okay, let's go ahead and try some example problems. The first one reads, how many grams are in 1.22 times 10 to the 23rd molecules of calcium chloride? So let's first start with what we're being asked. So we're going to go ahead and write how many grams of CaCl2 are in what you're being given. 1.22 times 10 to the 23rd molecules of calcium chloride. So in this example, we're starting at particles, right, the molecule, and we want to get to grams. But we have to get to the mole first. So in order to do that, we have to go from molecules to moles using Avogadro's number. So if we open up a parentheses and draw a fraction, we can say that in 1 mole of CaCl2, we have 6.02 times 10 to the 23rd molecules of CaCl2. Notice how we're putting the molecules at the bottom of our fraction so that we can cancel with the molecules of CaCl2 that's given in the question stem. So now we're at moles, right? We're at our bridge, and we want to make our way across to the grams. So in order to go from moles to grams, we have to find the molar mass of calcium chloride. And what we can do is that we go to the periodic table, find the molar mass of calcium, which is 40.078, and find the mass of chlorine, which is 35.453, but we got to multiply that mass of chlorine by 2 because we have 2 chlorine atoms present. So when you go ahead and take the sum of the 1 calcium atom and the 2 chlorine atoms, right, the weight of each, you end up getting a molar mass of 110.984 grams per mole. And that's the molar mass of calcium chloride. So when we go ahead and open up another parentheses and draw a fraction, we can place the 1 mole of calcium chloride at the bottom in order to cancel out the moles of calcium chloride that were left uncanceled from the previous step. And then we can place the 110.984 grams of calcium chloride at the top of our fraction here. So notice what's been left uncanceled is the grams, which is exactly what we want, right? So going ahead, when you multiply 1.22 times 10 to the 23rd by 1 over Avogadro's number, which is the same thing as saying dividing by Avogadro's number, right? Multiplied by the molar mass, which is 110.984, we end up getting 22.49177, and the number keeps on, right? The question stem is giving us 3 significant figures, so we have to round the answer to 3 significant figures. So the third significant figure is the 4 here, so we're going to look next door to it, and because it's a 9, right, it's above a 5, we're going to go ahead and round up. So our final answer is 22.5 grams of calcium chloride. Okay, everyone, so we're going to finish this lesson by going the other way around. So now we have grams and we want to get to particles. So the question reads, how many molecules of ammonia are in 18.0 grams of ammonia, or NH3? I encourage you to go ahead, pause the video, and try it on your own, and when you're ready, press play and we'll do it together. Okay, first start off with writing your setup, right? So put a question mark for how many molecules of NH3 are in what you're being given, which is 18.0 grams of NH3. We can't go from the gram to the molecule in one step. We got to cross our mole bridge. So we can go from grams to moles by using molar mass. So if we open up a parentheses and draw a fraction, we can place the grams of NH3 at the bottom and the moles at the top. But we got to find the molar mass. And when you find it in your calculator, the molar mass ends up being about 17.031 grams per 1 mole of ammonia. So we can put the 17.031 grams at the bottom to cancel, remember, and then the 1 mole of ammonia at the top. Now that we have moles of ammonia, now we're at our bridge, right? We can now easily go to molecules by using Avogadro's number. So let's open up another parentheses and draw another fraction. And we can say, okay, in 1 mole of ammonia, place at the bottom, why? So that we can cancel out the moles. we have 6.02 times 10 to the 23rd molecules of ammonia. And we write this at the top of the fraction. Why? Because we need molecules. And if you notice, all our other units have been canceled except for the molecule, which signals to me that we're done. Go ahead, place this in your calculator, right? So we have 18 grams divided by 17.031 multiplied by Avogadro's number. You end up getting about 6.362515, and it keeps going on, right? Times 10 to the 23rd. Now, the question stem is giving you 3 significant figures, so you have to round the answer to 3 sig figs. So looking at the third sig fig, right, the 6 here, you look next door, and because the 2 is below 5, you just keep it the same. So the answer is 6.36 times 10 to the 23rd molecules of ammonia. And that's a wrap for today, you guys. Hopefully, by the end of this lesson, you now understand how to convert between grams and moles and particles using molar mass and Avogadro's number. Because in the next lesson, we'll be moving on to 3-step stoichiometry problems, where we will be learning how to go from mass to mass using mole ratios. And if this lesson helps you at all, please don't forget to like and subscribe to my channel. And don't forget to download my free worksheet below in the description box so you can follow along with my examples. In the meantime, thank you for watching and happy studying.